Hello, and this time we're looking at volume of a prism, which is quite a nice thing to calculate. If you've done surface area already, then this is a lot easier than that. And for any prism, doesn't matter what shape it is, it's the area of the cross-sectional end, so the side that's the same all the way through, like it's been stretched back, that area times by the length of the prism. So in this case, we're going to have to do a composite sort of shape, and then times by the length. Here, it's going to be the area of this triangle times by the length of the prism. And that's it. That's literally all you have to do. So let's say the cross-sectional area times by the length. Now, I've been a bit lazy and put a cross instead of the word cross-sectional, and so don't get confused between that and the times. So we can do a couple of these examples, but just before I do, let's get rid of these, just to point out that a cuboid, it's not obvious which one the cross-section is, because is it that shape that's being stretched back that way, or is it that face that's being stretched back that way, or is it that face that's being stretched back that way? It's a prism in all three directions, so it really doesn't matter how you do that. And in fact, because the area of any of the rectangles is just the two sides times together, and then you're going to times by the length, it doesn't matter which way you think about it in terms of which one's the cross-sectional area, and indeed you can just think, well, just times all three lengths together. So I don't really think about this formula when I'm doing a cuboid, I just times the three dimensions of the cuboid together. This is kind of two cuboids together. You can almost sort of, imagine cutting that off, and so we can work out the area of these two bits and then add them together to get the whole area, and then once you've got the whole cross-sectional area, just times it by the length. So this is 6 times 2, which is 12, and then this little bit is 3 times 1, because of course if that's 1, then that's also 1, so that's 3, so that's a total surface area of 15, and I just times that by 8, and whatever that will be is the answer. So 12 and 3 is 15, times by 8 is 120, and of course it's volume, and we've got centimetres, so it's centimetres cubed. Three-dimensional. And here we need the area of a triangle, so that is 1/2 base times height, which is 8 times 15 and half it, and we've just done 8 times 15, it's 120. Literally just did that here. So we know it's 120, half it is 60 as the area of the cross-sectional face, and we're just going to times that by the length, times 11. I don't need to calculate for this, because I know that 6 11s are 66, and the extra 0 is 660, but watch out, look, they've changed to meters. So meters cubed. Because we're in 3 dimensions, we have 3-dimensional units. And this would be the same no matter what the shape is. So you could have a trapezium made into a prism. You just work out the area, 1/2 a plus b times height, where a and b are the two parallel sides. You add the parallel sides together, you half it, and you times the perpendicular height. And even if it's a cylinder, it's exactly the same. You just do the area of the circle, pi r squared, and then times the length of the prism. Although with cylinders, we often call that the height of the cylinder. Don't know why we make a distinction for cylinders. Maybe because people are used to a tin of beans standing up on the circle. So often that formula is given as pi r squared h, because you're timesing by the height, not the length. But these words don't really mean anything. You can call it the length, the height, Bob, Fred, I don't care what you call it, as long as when you're doing area, the base and the height are at right angles. So if you have a triangle like this, and that's your base there, then your height has to be the perpendicular height. So as long as you're doing things at right angles, you can call them what you like. If I've missed anything out, you can let me know in the comments, but otherwise, good luck with that. Cheerio.